Ever wondered how AI models are tested for real-world smarts? Let's dive into a breakthrough study that's redefining how we measure machine intelligence. It's not just about size or speed, it's about what models can actually do. Here's the problem. While Arabic is one of the world's most spoken languages, most AI evaluation tools focus on cultural or linguistic aspects, like dialects or religious texts. But what about subjects like chemistry, physics, or coding? These are critical for real-world applications, yet there's been a glaring gap. Enter 3LM, a revolutionary set of benchmarks designed to bridge that divide. Think of it as a trio of rigorous tests for Arabic language models, pushing them to tackle science, math, and code. Let's break down what makes 3LM groundbreaking. First, the native benchmark. This one uses real questions from Arabic textbooks and worksheets, sourced from schools across the Arab world. These aren't random prompts. They're structured to test deep understanding, like solving a physics problem or explaining a biology concept. Imagine a library of exam questions, carefully curated to challenge models on foundational knowledge. Then there's the synthetic benchmark. Here's where things get clever. Researchers used AI to generate new questions based on the same textbooks. It's like a robot tutor creating practice problems, ensuring a wide variety of challenges for models to tackle. This synthetic data expands the testing scope, making it harder for models to rely on memorization. And finally, the code benchmark. Coding is a huge deal, but most tools are in English. 3LM fixes that by translating two popular code challenges into Arabic, with a human touch. Experts reviewed every translation to ensure code snippets and logic stay 100% accurate. No more AI misunderstanding a Python function issues. But here's what makes 3LM truly special. It's open source. All three benchmarks are publicly available, so researchers worldwide can use them to improve Arabic AI models. The team didn't stop there. They tested over 40 state-of-the-art models, revealing insights into how these systems handle science, math, and code. Now let's look at the results. Using a leaderboard called Open Arabic LLM, researchers evaluated models on metrics like Pass at 1, which checks if code works, and Rouge LF1, a score for translation quality. For example, Qwen-2.5-72b nailed coding tasks with a 72.39 score, while its smaller sibling, Qwen-2.5-7b, still managed 59.8. But here's the twist. When it came to Arabic language tasks, those smaller models struggled. Size helps, but it's not the whole picture. Translation results tell a similar story. Bigger models like Llama-3.3 instruct scored near perfect, but even mid-sized models like Fanner 1-9b hit 70.32. It's like comparing a luxury car to a compact one. Both get you there, but the bigger one handles rougher roads. But here's the key takeaway: size isn't everything. A model might be a coding genius but trip over language nuances, or vice versa. Take this biology question. What's the main role of pSii in photosynthesis? The answer isn't just a fact. It's about electron replacement, a key step in energy conversion. Now compare that to a chemistry question about solids. Why does ice melt? Because hydrogen bonds are weaker than ionic ones. These aren't random facts. They're puzzles that test understanding, not just memorization. This isn't just for researchers. By seeing how models tackle these challenges, we learn if they're grasping concepts or just guessing. The results could shape smarter AI, ones that reason, adapt, and truly understand the world. So next time you see an AI answer a tough question, remember, it's not magic. It's the result of datasets designed to push boundaries. Stay curious, and let's keep exploring the future of knowledge together.